Hello and good morning. And we were too busy chatting at the back of the stage, and now we've had to do an awkward little run. So thank you for being patient with us. OK, right. What are we talking about today? Autonomous now. Now, self-driving cars have actually been a topic of discussion for a really surprisingly long time. In fact, as early as 1925, an electrical engineer called Francis Houdina from New York operated a remotely controlled car called, get this, Chandler, in a demonstration between Broadway and Fifth Avenue in Manhattan. But if we fast forward to today, and a myriad of companies benefiting, sort of touting the benefits of self-driving cars, the journey hasn't been straightforward. It arguably began in earnest in around 2010, and it has had significant investments, I think around $50 billion US dollars since that time, Wave potentially tipping that over to $51 billion. But with all of that going on, the question remains, how will self-driving cars become a safe, practical, profitable, and viable reality? Big questions for a Thursday morning, but here to put us out of our misery are our wonderful panelists of experts. So, joining me on stage, we have Nils Jaeger, President, Volvo Autonomous Solutions. We have Danny Shapiro, VP of Automotive from Nvidia. Helen Pan, General Manager and Board member for Baidu Apollo. And last but not least, Paul Newman, Founder and Chief Technology Officer for Oxa. OK, Nils, I want to start with you. So Volvo Autonomous Solutions sits in the Volvo group, not to be confused with Volvo cars, just for clarity. For those who may not be familiar, can you tell us a bit about the first production-ready, fully redundant autonomous truck for on-highway transportation, quite a mouthful, that you recently revealed in Las Vegas?
Yeah, thank you. Yeah, last month in Las Vegas, we introduced our all-new VNL Autonomous. That is a purpose-built, purpose-designed truck for the autonomous use case. So scalability is the name of the game here. This shall come from the, or will come from the production line. And with this truck, we target the US long-haul segment. So we will operate between hubs. And the first two launch lanes for us will be Dallas-Houston, and then the second one will be Fort Worth-El Paso. The first one 250 miles, the other one 600 miles. And in that geography in Texas, you have extremely high traffic volumes or freight volumes, so it makes a lot of sense that we start in that range. Important is we have built now a truly autonomy-enabled truck with full redundancy, and we're integrating that now with the Aurora driver. Aurora is our partner. And then, of course, when we've done the integration, we will go out, do the testing, and then ultimately remove the safety driver.
I want to come back to the Aurora driver in a moment's time. But before I do, Helen, tell us about the Baidu Apollo driverless robotaxi. How many are operating, and are they truly driverless?
Okay, that's a really good question. Yeah, we have more than we probably have like 6,000 rides daily. And we've been operating in 11 cities. And 4 of the cities is offering driverless service to all the public. And in Beijing, Shenzhen, and Chongqing, as well as Wuhan. And in Wuhan alone, this region, we've been able to operating up to 3,000 kilometers. And with serving 7 to 8 million populations. And with all those service ride, by feedback from the customer, continue gradually, we can be improving our performance.
You recently announced the 6th generation robotaxi, which claims to have 60% lower cost than its predecessors, costing around $28,000. How have you reached that 60% cost reduction?
That's a really good question. Yeah, actually, Baidu since working on the autonomous driving technology more than 10 years. I've been in this field for 9 years already, and in this particular field, through the years, we already accumulating more than 100 million kilometers with all those public road driving, autonomous driving service, and also the testing. With this, we've been able to learn a lot from the beginning to the end. So we have fully understood what we really need, what really does not need. And putting the safety as our top priority, we build a lot of redundancy, like what Nils was mentioned about it. So we have a redundancy in vehicle side from autonomous driving systems, as well as the algorithm, the autonomous driving learning algorithm. So combine all together, so we be able to know what can be fully driverless. By doing so that's why we understand what's really need, what is really not need. So, and on top of that one, combined with the manufacturer in the China supply chain, we'll be able to really drive down the cost significantly.
So we've got themes of 100 million kilometers, safety and redundancy, and of course the supply chain. All themes which I'm sure we'll return to as we go through this discussion. But Paul, I want to come to you. Now, Oxa creates, and I've lifted this totally from your website, the only universal platform for autonomy. Can you tell us what that actually means?
Yeah, well thank you. So Oxford's mission is universal autonomy. That's our North Star. And the idea there is that actually the act of driving, of deciding where you are, what's around you, what you should do, and what you should now share, that's kind of universal. And the way we think about getting there is by driving somewhere before everywhere and making it very easy to drive in lots of somewheres. So we talk about our software because we're a pure software play that allows vehicles to become autonomous. We think about being available, configurable, and explainable. That's quite nice because I do like a good metaphor because we call it ACE, and who doesn't want ACE software? So we want it to be like that, yeah. We want it to be available to other parties so they can use it, available in different places, and then configurable, so easy to configure to new routes, like a bus route. We're not doing PaaS cars, like an industrial route, and obviously explainable. So that North Star is universal autonomy because surely it can't be a different skill to drive in an airport, to in a mine, to in a warehouse, to in a city. And the way you choose which places you do first, your somewheres first, is about how quickly you can configure it. And that configurability is obviously AI-driven with foundational models and Gen AI. So that's how it kind of all fits together. And I love that because how bold and scale up should have a bold vision, like software will drive vehicles. Yeah. How to get there, that's about executing sensibly, and you should do that in an ACE way, so available, configurable, explainable.
Available, configurable, explainable. Also sounds like excellent attributes for a new graduate in your team as well. And somewhere for everywhere, that sounds like a lovely, philosophy of life as well. Yeah. Use cases is something that you've touched on there as well, and that is something that I will come back to very shortly. But before we do, Danny, it's quite a moment for Nvidia at the moment. I mean, in fact, I want to share this. I recently saw a BBC article titled, "Why is Nvidia boss the Taylor Swift of tech?" Quite a headline. But Nvidia makes end-to-end autonomous vehicle, also makes an end-to-end autonomous vehicle development platform. And that platform consists of both the AI infrastructure, in-vehicle hardware, and software. Talk to us about that platform and how does it differ, say, from what Paul is doing at Oxa?
It's a great question.
Oh.
It's a great question, and the reality is it's not that we're doing something and Baidu's doing something and Volvo's doing something and Oxa's doing something. We're all kind of doing it together. Nvidia is really at the core of this. Baidu, Volvo, Oxa are all partners of ours. So we're developing the core technology. We're developing hardware, we're developing software, and our partners, customers, are building on top of that. The reality is you need 3 computers to do this. It's not just what goes in the car. You need the data center for training the AI, for the Gen AI, and now our AV 2.0 type of work that we're doing, just changing how we're approaching this problem. It's a very challenging problem, and I think that's the reason why we're still not there. It's much more complex than anyone imagined 10 years ago. So you're training in the data center, but then you need to also simulate. You need to test and validate. So a second computer is basically running this whole simulation to see what you have created, will it actually work? And then there's what goes inside the vehicle. A supercomputer that's automotive grade, that's able to process in real time and run these models. And so we're really working with hundreds of companies all around the world on the data center side, on the simulation side, and the in-vehicle side. And then with that system, it's really continuous development. The software is never going to be done, right? Just like your phone, you're always going to get updates. We've been talking about software-defined cars for a while. Some automakers are there, others are playing catch-up. But the concept is your car is just going to get better and better, or your truck, or your public transit. And we'll continue to work with companies forever to develop that software and really bring this evolution to market. There's a lot of testing going on here in the UK, throughout Europe, China, certainly in California and other parts of the States. I see tons of robo-taxis and autonomous vehicles all over the Bay Area. And it's coming. Everything will be autonomous. And so we keep getting closer and closer. We're going to talk about safety. I know that's really the key thing for us. And this is where simulation plays a huge, huge part in ensuring that these systems will be safe for everybody here before they actually go on the road.
So we've got a few things to discuss here, not least the complexity that we've already touched on a little bit, not least the specific use cases that ultimately will make it profitable and address all of those technical hurdles and policy hurdles along the way. But I want to zoom out for a second. Why? Why are we actually doing this? Why do autonomous vehicle solutions actually warrant our time and effort and cash? What's the value? And I'll open that up to anyone who's feeling brave.
Well, I think, the obvious thing is, and everybody knows the stats, in the States, it's like 40,000 people are killed. Globally, it's like 1.2 million. It's crazy that we're still killing each other on the roads. So I think this technology is going to enable the roads to be a lot safer, more energy efficient. It took me an hour and a half this morning to get from Heathrow to here. And I think we can see how automating all of that will make us a lot more efficient. So I think there's just so many benefits down to enabling mobility for people who can't drive as well.
Maybe I'm cohere a little bit. Danny's point is really good. I think top priority, exactly like Danny mentioned about the safety. Safety is a top priority we want to see. We see, there's 94% of the human error causing the car accident. And with this AI algorithm and building on top of the autonomous driving hardware and with the vehicle innovation together, I think we'll be able to make sure drive down this number. And being driving down, we can bring a more safer for the environment, safer transportation for the society. That's actually our top number goal. And on top of that one, I want to bring in another thing. This is my second time in London. I really enjoy this city, and it's beautiful. Particularly in summer, it's very wonderful. The weather, sunshine, and everything, I really enjoy it. So you notice when you're into any large city, Manchao, Helen regions, you notice they have very sophisticated transportation system. So they have subway, train, they have variety, even scooters, electrical scooters and bicycles and variety. But on top of that one, I think autonomous driving can bring this, break down the service to providing sustainability. The reason why, when you have this driverless service available to everybody, you could be able to make sure more people to willing to share. And you bring down to be smaller vehicle, right? Now, if you use the human mankind operation, you only can providing very large transportation. Many people hop on the subways and the large buses. But with now, we can meeting the diversified requirement needed from the individual to meeting them separately because we have this technology and the efficiency there, so we can bring more sustainability. On top of the EV vehicle, everything, we can also bring more environmental for the society by sharing.
Yeah, I think I look at this from a more holistic way, and I think it's almost a contradiction that an industry which aims to add a lot of safety to public roads, but also to other sites, that is judged by others whether it's safe enough. And I think this discrepancy needs to be analyzed a bit further. But when we speak about safety, we immediately think about public roads, but we operate also in an industry vertical which we call quarry and mining. And if you think of mining applications, you actually have an environment where you have a lot of injuries, you have a lot of fatalities still today. And here it is very important that we remove the human being from this hazardous environment by bringing autonomous technology.
So look, yes, all of those things, right? And they're the things you lead with. So it's great going last because I can go and I can do a Columbo moment because there's extra stuff as well, right? So, you take GCP, Azure, or AWS, and new businesses are formed that were unimaginable before you had large-scale elastic compute available easily. And I think the same way about vehicles. So, but frankly, we haven't really changed vehicles since someone sat on a pony and pulled a trap. Yeah, you still got to have one person in a vehicle, one person per vehicle, not one person outside a vehicle looking after 15 vehicles. And so much of the vehicle is built around of having us in that vehicle. So let go of that. Let that be a platform. You can start to think about redesigning the vehicles, new form factors, new kinds of work, new economics, yes, new safety regimes. And then because of that, you get these second-order effects. And I've got a whole bank of second-order effects that turn out to be really quite surprising. So early in my career, I've been doing this since 1995. I'm not sure if that makes me good or bad at it, because I'm still doing it like 30 years later. But I'll be positive. Some of the first applications we did was port automation, and it's still running in Sydney. And do you know what one of the main advantages were? Yes, there was safety. There's been no accidents in that port since. It was that they turned the lights out at night. Yeah, because it didn't need to see, it doesn't have human vision. Now, I'm not saying that it's lights turning out that's going to help with autonomous vehicles. What I'm saying is that when you remove those constraints of having one person in the vehicle, you then have industries with all the thousands of people that can innovate in their own industries using that technology to build something new. And of course it's safer, and of course it's more efficient. But if you're thinking about starting something that really changes how people and goods move, it's got to be removing a thing that's been true about vehicles for about 3,000 years of having one operator per vehicle and the operator being in the vehicle. And that, for me, is a huge motivator.
Well, Paul, that's so cool. But what I'm really excited about is once cars stop running into each other, you totally change the design, right? They don't need to be made out of reinforced steel. You don't need all the airbags. You don't need everything else. Yeah. And they can be these places that are living rooms and offices and everything else, or little hotel rooms, right? You get in and you drive to wherever you need to go, or you're driven wherever you need to go, and you just sleep in the vehicle. Nils, I think for your industry too, I mean, there's just a shortage of truck drivers globally. And so being able to have this technology supplement what's really needed for society when we don't have the workforce available to it, I think is going to be really critical too.
Yeah, I agree with you. There's, of course, a shortage of truck drivers, but my way to look at it is that we're not replacing truck drivers. We're bringing a new transport system, a transport system which is competing with, freight by sea, by rail, and by truck. But for that new transport system, you need a new ecosystem, and that's what we're building, and that's an important part. But we believe that there will always be, for years to come, the needs of truck drivers.
It's so fascinating because listening to you talk there, what you're describing is an opportunity to fundamentally rethink how transportation systems work. Helen, in your case, you're saying, well, actually, cars could become a scaled-down, flexible version of a public transportation network or mass transportation network. We've got the secondary and tertiary unintended and intended consequences. We've got ways in which, vehicles could be redesigned around these new use cases. But it is interesting that actually none of us on this panel represent passenger car OEMs. And I imagine that there's a bit of a kind of, how do we square where we are now, where we have a variety of level 2 plus, a bit of level 3 out on the road, and this full autonomous future. And actually between those two bookends, we have this slightly messy middle in which the reality doesn't always match expectation, leading to an over-trust in systems or people not interpreting the systems in the right way. And that has resulted in a number of safety issues, and albeit, yes, they are slightly more anecdotal than hugely translating across loads of data. But how do we navigate that weird, messy middle between advanced driver assistance systems that are pretty sophisticated and this full autonomous future, which can unlock all of those different use cases? Any thoughts?
I can have a go. And I think it's good to call out as a messy area. And I think there are probably several ways to navigate through that. Forgive the pun. So one of them is, I've got two things to say. One of them is, I often get asked, when are we going to, and then the question mumbles into, have vehicles that don't need windscreens and stuff like that. And I always answer that with when, where. So tell me in what places you want that. And I think that couples, this is to drive many somewheres before everywhere. I think that couples to a question that is one way to answer give some color around the safety thing is the vehicles have to be able to self-appraise their ability as are they qualified for this place. Yeah, so imagine you were a lawyer and someone asked you a question about a legal topic and you go, that's not my specialism. You would then say, oh, you need to talk to a different lawyer. You get asked a question and you can check that against your qualification. And we think that qualification is about the kind of place that you're operating in the route, which to your point is exactly where the rehearsal comes in. So you wouldn't rehearse entire planet, you would rehearse the number 7 and 17 bus routes. Right? And then so the number 17 and the number 7 bus route, you know how that's going to work, and then your assurance comes for that. And the trick is then to do lots of those places quickly. This is why we're a bit more skeptical about the everywhere passenger car. That you say, I have to solve everywhere and then it's all good. We think you can blend that by making commercial services where people want them. And we think you end up with the generalization by having done lots of somewheres. And on the way to doing that, you can say something strong about safety numerically. Is one way to do it, right? And I just think you need to have a credible, coherent case about how your technology, how your testing, how your assurance, how your insurance, how your development and your explainability all fit together. And it's a nuanced and rich answer. Anyone who gives you a simple answer to that question should probably jog on, because it ain't simple.
Helen's laughing there. I want to come to Helen.
Yeah, I just want to add on a little bit pause comments. I think it's a good point. So, which is there are multiple dimensions to address this question. So, first thing I was cohere with, Paul was mentioned about it. So, besides L2, we talk about L2 plus, very close to L3, but nobody really touched L3 because there are no one, who is responsible for it. And then we talk about L4. And actually, ultimately, eventually, we want to reach L5, which is you can reach mobility, driverless everywhere, anywhere. And it takes a long time to reach to that point. Before we reach that point, I think the industry and the consumer has diversified need. We want to address it. And also in different regions of the country, like the big cities and the countryside, they have different need. So to meeting all of them, so both technology will exist together. And to address this technology, recent development in large language model, inspiration by the LLM, and implementing this similar technology in autonomous driving, providing end-to-end solution, we'll be able to address both markets. So we can be more diversified, meeting both of them. So they have one foundation model. This foundation model can tailor towarding model to the L4 driverless technology, and you simplify it with customized with a lower cost BOM solution to meeting the L2 application for ADAS plus service, so which is what Baidu was doing. So we're actually targeting both market and we're providing this solution. So working with the existing OEM in this technology to make sure they deliver this ADAS plus service as well. We're also developing the robot taxi service directly bring to the population for the large cities. And you notice it's really sweet zone for the driverless technology deploy, starting with large city. That's what we do. We start with Beijing, Shenzhen, Wuhan, and Chongqing. And you can notice we didn't go to little small town because you need service, you need really population and usage in there. So which is as also this technology require this kind of large city to be able to use it. And all the feedback from the customer and all the the corner cases we're facing, we can address and use it. So in this way, we can continue to advance this technology, and all the learning from here also can back translated to the L2 plus service as well.
You touched there on end-to-end autonomy, and that's something that we're starting to hear more and more around in this AV 2.0, and that's something that I want to come on to next. But before I do, Nils, you work with customers who are working typically in quite dangerous situations. What's their sort of understanding of risk and perceived safety, and how safe does something have to be for it to be deployed in some of these environments?
Yeah, thank you. Depends a little bit on which industry vertical. When we speak about quarry and mining, maybe I should focus a little about that one. In quarries and mining applications, safety is the major concern. And if you think about where do we bring the biggest value for that industry vertical, it's all about safety. That's what our customers are asking for. How can we make sure that we remove the human being from that hazardous environment? And in order to do that, of course, you need to have a complete safety case. In the fact of, we have a customer in northern Norway where we removed last year the safety driver, and in that case we had to get basically a license to operate from the Norwegian road authorities. So you work very close with the authorities and you explain your safety case and the specific environment what you're doing to keep that area protected and safe. So it's a little bit side-by-side dependent how you do that, but nevertheless in this use cases, you really work together with local authorities. Most of the time you have, in Sweden, Norway, Italy, you have different requirements, so you have to be specific of wherever you are. But it's very important that you control the site, that you have very good control over who is accessing the site and who is within the site and who is not within the site. But again, number one reason for customers to work with us is safety. It's not immediately productivity and efficiency. First criteria is safety, because you have so many accidents. Another reason is, however, also that if you go to sites in Australia, for example, you have very far remote locations. And here you fly the drivers, the workers in and out. And here, of course, you have an enormous cost advantage if you can take away the drivers or the operators of the vehicles. But also in Australia, when we talk to the big customers and we work with them, safety is super core for them in their decision making.
And so from that standpoint, on the safety front, I think the reason why we still don't have things out there is there's just too many things that can possibly go wrong, right? And we can't write code, you can't program a system to anticipate that. And so getting back to your question about these end-to-end foundational models, it's not what we've been doing is training something, how to recognize signs, how to recognize lanes, how to recognize people, right? And so we're going through this list. It's not programming like it used to be, but still there's all these different neural nets that are running in the car. And instead, we're kind of leveraging the concept of what's happened with ChatGPT now in terms of building this massive large language model. The language now is not words. It could be pixels coming in from front-facing video camera. It could be radar. It could be LiDAR. But now it's holistically understanding the environment just like we do, right? We look at everything all together and then can make decisions and act accordingly without actually having been trained on that specific incident. And so it's moving from this detection, perception, and planning, all separate things, and integrating it as a single end-to-end model that really is anticipating behavior, right? So now we're able to detect what kind of behavior. Is there somebody driving aggressively? Is there a motorcycle, splitting lanes? Whatever it may be, is there construction? And then that way, we're going to be able to get to a system where we can drive more places without actually having been there before.
So just so that we're all on the same page, I want to check that I've understood this correctly. We're at this sort of inflection point where this industry is evolving to accept AV 2.0, in which we're moving to these large language models, where instead of having to do hundreds of millions of miles or kilometers of driving, understanding and identifying all of these weird and wonderful edge cases to train the system, actually, it's a bit more like ChatGPT, and then it can learn as it goes along.
Well, it's still going to learn in advance, right? I mean, you're still going to train it. And this is where simulation comes in, too. So we can create all kinds of scenarios that the car may never encounter on these test drives. And I think that's what's key. So a combination of real miles, data, as well as simulated data. But yeah, it becomes basically aware of how to handle these situations. Again, you're scanning 360, so the kinds of dilemmas or issues that we all face when we're down looking at our phones or not paying attention or whatever it is, the car is going to sense all that and be able to anticipate and prepare. So there isn't this last minute, oh my God, I need a break. It will have seen that there's an issue ahead.
And how much does this approach accelerate the trajectory to getting this to a much more commercially viable place? Has it been a case that we've been doing this and suddenly this makes it astronomically scale?
I think so. Again, though, I think each region, as Paul's saying, is going to be different. There's going to be different use cases, as Nils talking about. Different countries are going to have different laws. But we're definitely seeing this new approach being much more successful. It's not just that there's one end-to-end model, though, that we can't explain, but it's still many layers of different systems and some rules-based things and some other safety mechanisms that are in place. But the ability to handle the long tail of random events, we're going to get a lot closer to being able to handle that through this new technology. And it's just going to keep getting better and better.
Yeah,
that's the nature of all this.
I want to pick up on that point because there was something you said really importantly there. Architectures eat algorithms for lunch every time. And the way you do this is having an architecture that's evergreen and can always bring in and leverage the latest inventions that we have in the AI world. And a great example of that is the use of foundation models or LLMs. They're another very, very compelling, flexible tool that can perhaps fill in some of the gaps in autonomous systems that were very hard to engineer before. And I'd say very, very strongly that the best systems are the ones that have a multiplicity of ways to solve the problems by architecting it very well. Architecting it for what you've yet to invent. This is not the moment we go, there was suddenly that. Architecting for the future and architecting that you can reason about the reasoning that you're doing. And I think that's really important. That comes to the explainability of being ACE. I need to explain what I engineered. I need to explain what was learned. And when you've fixed something or you've upgraded it, you need to explain that as well. So there is something remarkable that has happened in the past couple of years, and the tools have become readily available, but it's still architectures that win, not a particular algorithmic approach. And I think that's really important, especially when you come to reasoning about safety and what that's going to be, and especially when you come to reasoning like, this is not what I expected to be happening, therefore I could be out of domain. I think that's really important, and I don't think we should use things like AV 2.0 is a thing that arrived. It's more blended than that. It's not like there was a step change. There was new technology that came along, but it's architectures that win. So and I really, really strongly index on that, and I really liked your point. We call it compound systems. Yeah, you would choose the best tools, the best way to engineer it that you can. Like a TV has lots of circuits in it. Computers have lots of things that make them good. Thor is going to have loads of things that you've developed over time that's going to make that transformational, and I think we should index very strongly on that.
Helen.
Okay. So I'm adding a little bit here. So exactly mentioned. So when we're doing, particularly, I think in the past of 10-year dish, Nvidia did a good job. Really bring down the cost, competition costs going down. With that, we can afford a much larger model. And back to 2017, the first transformer paper come out. Attention is all you need, and be able to bring this new architecture and be able to have this foundation changing. So with all those things, you can think about the more like a simplified way to look at it. If you have a large well, so it means you can conserve very big, large model. So there are a lot of potential into it. So if you feed into with lot of data, then you can be able to starting those potential to show up, to showing this model has this capability to be able to understand the environment, and knowing where you are, and combine together, make a judgment, where should I go? So in this way, we're solving a lot of, in the past, of a discrete solution. So we have the perception, we have a localization, we also have the PNC, planning, control. So now we all combine them all together. So in this way, you can be able to make from the end-to-end solution. That's why I think the large model bring to this new revolution. And as with the computation continue increase with the cost lower, so we will be able to even afford even bigger. So we can be able to forcing more potential. And the beauty of this one is because it's changing the development cycle from the traditional approaches, a lot of rule-based. You still have a rule. You won't really get rid of the rule. Like for me, very simple. Green light means you can go, and red light you need stop, yellow you need a yell. So that still exists. There are a lot of basic rules, fundamentals still exist, but you won't need so many rules. You need very simple rules. And human driving also based on some rules, but very simplified rules, high-level, abstract understanding of rules. But all the rest will handled by the intelligent for AI algorithm together. So in this way, we can be able to address a lot of corner cases. And so we can also have this reliability, reconfigurability, and on top of that one, we can improve the, it's more like reliability and safety.
Oh my goodness me. This half an hour is not enough for this conversation. We've spoken about various different forms of somewheres before everywheres, a changing set of tool sets that can really, really future-proof these architectures to make this possible. We've spoken a little bit about use cases. We've spoken a little bit about prioritizing safety. I think that's something that we can all agree on before productivity and cost. But 10 seconds per person, I know this is very hard. If I could grant you one wish to make mainstream adoption of autonomous technologies that much easier, what would your one wish be? And very, very quickly, because the thing is flashing, it's telling us that we're totally running out of time.
Well, I think that the problem is, or one of the problems is that everybody has their own idea of what this technology means. You say autopilot, what does that mean? Different regions have different rules. So I think we really need to put together almost like an autonomous vehicle driver's license, right? We all need to take a test at the DMV to drive. And so if there was a system or hierarchy we put in place of capabilities that vehicle manufacturers needed to pass, and basically we see simulation as a way to do this. It's not just a simple test, but a very exhaustive test of everything. And so depending on how your vehicle performs, then people will know what it can and cannot do. And so working with government entities is something that we're doing to really try to bring this to life and make it a system that people can understand.
Any other wishes, very quickly?
Okay, I have a very simple wishes. For me, I think working for this industry for so long, I want the publicity to have more open-minded to this new disruptive technology. I want the government to be more tolerant for this new disruptive technology. So you have more open-minded, welcome this new technology to change. And I think we promise all together working in this field, we want to make sure this technology bring a safer and better transportation to the society.
Thanks a lot. For me, coming from Volvo Group, we are the ones who invented once the safety belt, the 3-point safety belt, which is identified as the one most important single invention to protect lives. So from my point of view, I believe that autonomous technology can be the next big thing, which can protect as many lives as the safety belt. But I really want, if I have the one wish, that this technology is by everyone only deployed when it's truly, truly safe and that no one is taking any shortcuts.
To enable it, much, much, much higher quality conversation about what AI is and is not in public, private, and industrial discourse. Otherwise, we're going to get stuck.
Well, that is an excellent point to end on. Thank you so much. I know we probably generated more questions than we provided answers, but thank you so much for joining us in this discussion. Please do make sure to continue it off stage. And in the meantime, please join me in thanking our wonderful panelists.